This is your lesson for matrix inverses found in Glencoe 4.7. Example 1, verifying inverse matrices. The approach I'm going to take to solve these will be different than your textbook, and it also skips ahead content-wise. So make a decision now if you'd like to figure out how to find the inverse of a matrix or if you'd like to proceed by following your textbook. The textbook describes the fact that when you multiply two matrices by one another, if they are inverses, you will receive the identity matrix, which is why later on you can use this to solve systems of equations, okay? For me, I think it's just simply easier to find the inverse of one of the matrices and determine whether or not it actually is the inverse of the other one, okay? So looking at A, I have matrix X and matrix Y, and I'm told to figure out whether or not they're inverses, okay? So the first thing I should do for X is determine what his determinant is, because that's one component of finding his inverse. So to find his determinant, I'm going to do downward minus the upward diagonals. So downward, 2 times 4 is 8, minus upward, negative 1 times 2. That's going to get me negative 2. So the determinant on this one is a determinant of 10, okay? So now, to find his actual inverse, I need to do a switcheroo of things. So I'm going to divide everything by the determinant, or essentially multiply by 1 over the determinant. So the downward diagonals are going to change location. So the 2 and the 4 are going to flip-flop. So this is now going to be a 4 in the first element, and the last element will be a 2. The upward diagonals are going to switch their signs, okay? So now I'm going to put it all together. I'm going to divide each of those terms by 10, or essentially just multiply 1/10 by each of them. 1/10 of 4. Well, that's going to simplify to 4/10, which simpler is 2/5. Notice, Y's first element is 1/2. Without going any further, I can already tell you that these are not inverses of one another. Okay? Not inverses. So now, let's do the same for B. Given P and Q, I'm determining whether or not they're inverses of one another. So to determine the inverse for matrix P, downward diagonal, 6, minus the upward diagonal of 4. 6 minus 4 gets me 2. So I'm going to take 1/2, or divide everything by 2, when I do some switcheroos. Downward diagonal, change locations. Upward diagonal, switch their signs. Okay? So now, 1/2 of 2, that gets me 1. 1/2 of negative 4 gets me negative 2. 1/2 of negative 1 gets me negative 1/2, and 1/2 of 3 gets me 3/2. Notice that matrix Q and the inverse of matrix P are the same. Therefore, these are inverses. Once again, make a decision. Which method did you like better? Example 2 deals with finding the inverse of a matrix and determining whether it exists or not. Okay? So whenever I'm finding the inverse of something, it's essentially just raising something to the negative first power. So matrix R to the negative first power. The first step to finding its inverse is finding its determinant. So downward diagonal minus the upward diagonal. So 8 times negative 3, that gets me negative 24. So negative 24 minus negative 24 equals 0. I want us to think about why the matrix's inverse does not exist. Think about it. When we're doing an inverse, we're dividing everything by the determinant. Can we divide by 0? I think not, so it does not exist. A mathematical way of saying D and E does not exist. Well, let's try example B. Maybe that'll give us an inverse. So once again, we are going to do the downward diagonal minus the upward diagonal. 6 minus 5 equals 1. This is probably one of my most favorite ones to find the inverse of, because dividing everything by 1 really just gets you itself. So the downward diagonal is going to change its location, and the upward diagonal changes its sign. So we literally can just leave this as our answer. This is our inverse. The last example of your inverse chapter is a fun one. It's a decoding example. So I'm actually going to leave it up to you to try by reading your textbook. Notice it literally will walk you through exactly what to do in order to solve its message. Have fun!